Whenever it likes, the universe strikes me with wonder, shocks me with awe. The cosmos needs only a moment to subvert my thoughts and rivet my attention, a flash disruption of daily life. I do not have mystical experiences. For me, all it takes is the actual, factual reality of the universe. Its beginning, its size, its structure, its future, its far future, its fields and particles, its laws and regularities. This is the realm of contemporary scientific cosmology. How to make sense of cosmology. How to see the big picture of the puzzle of the universe, piece together all the new discoveries. How to seek the fundamental nature of the cosmos. I hear of an emerging way of thinking called philosophy of cosmology. What is philosophy of cosmology? I'm Robert Lawrence Kuhn, and Closer to Truth is my journey to find out. Philosophy, I know, is the search for the fundamental nature of things. That's why philosophy of cosmology intrigues me. Can philosophy of cosmology elucidate the fundamental nature of the cosmos? When I find that a conference of cosmologists and philosophers will be held in Crete, Greece, I decide to attend. The idyllic shores distance me from my usual urban habitats, clearing my head, honing my quest. To begin, I seek out a philosopher of science at Rutgers who co-leads a major project on the philosophy of cosmology, Barry Loewer. Barry, I've been fascinated by cosmology my whole life, and I also love philosophy. I was really intrigued when I saw you were involved with the concept of a subfield, philosophy of cosmology.
Plato and Aristotle and the whole tradition in philosophy have been interested in issues in philosophy of cosmology, from Leibniz and so on. But cosmology itself developed enormously from 1915 or so on, with the advent of Einstein's theory of general relativity and all of the incredible observational results that cosmologists have obtained from Hubble onward. So cosmology itself has changed a lot, and there hasn't really been, within philosophy of science, a philosophy of cosmology subfield that's been so well delineated until fairly recently.
So what are the general big categories?
So for the philosophy of cosmology, first is the question of what is the nature of space and time? Then there are the contents of space and time. What is there in space and time? Is matter in some sense? And there's the question, what is matter? Well, matter consists of certain kinds of particles, protons, neutrons, neutrinos, electrons. What are these? Well, the usual view within physics is that these are certain kinds of excitations of fields, so that the basic thing that exists are fields. Well, not quite basic, because this is all described by quantum mechanics. And the basic object in quantum mechanics is what's called the quantum mechanical wave function or state. Then there's the question of what else there might be. And one view is that in addition to there being space and time, and there being the stuff that occupies space and time, there are also laws, which in some way govern or evolve or develop or describe the patterns and regularities in the universe. I myself am especially interested in a philosophy of science question, or a question of metaphysics. What is the nature of a law of physics? That's a different question from what are the laws of physics. That's a question for physicists.
And how does this apply to the understanding of the progress that cosmologists are making today?
I'm not completely sure that an answer to the philosophy question will be of much help to the physicist question. Philosophers have to look at what physicists are doing to understand what laws of physics there are in order to say something about what laws of physics are. But I'm not sure that physicists have to know what philosophers say about what laws of physics are. And in fact, I found in my own conversations with physicists that they're incredibly confused and all over the place when they try to deal with the philosophical question.
Some physicists say we don't need philosophy, or the only philosophers we need are those who can keep all the rest of the philosophers off our backs.
Well, I think there's something to that. I'm a philosopher of physics who knows some physics, but I'm not an expert in the way a physicist or a cosmologist would be about some of the issues that arise, at any rate in cosmology. But I am an expert in how to understand the structure of concepts and their relationship to each other. And philosophers get used to asking certain kind of questions and thinking clearly about certain issues. And I can think of some places where, in fact, I'm fairly confident that physicists have, chasing their own tails because they've been conceptually confused about certain issues. The big issue in the history of recent philosophy of physics has been the problem of understanding and interpreting what quantum mechanics is really about. That's a whole...
To populate the philosophy of cosmology, Barry, as a philosopher, offers three big categories: the nature of space and time, the contents of space and time, namely energy and matter, the laws or regularities that describe how things actually happen in the universe. Barry's a philosopher. How would a cosmologist, the other end of the phrase, assess the philosophy of cosmology? I ask an astrophysicist who spent 25 years with the Hubble Space Telescope and who helped determine the expansion rate of the universe, Mario Livio.
Mario, if we reflect on the so-called philosophy of cosmology in saying what are the implications of everything that we're learning in terms of human place in the cosmos or the nature of reality, what can we begin to say?
What we have discovered in the past century or so is that from a physical perspective, our place in the cosmos has become smaller and smaller. It all started with Copernicus, who taught us that we're not the center of the solar system. Then we discovered that in the Milky Way galaxies, there are billions of other solar systems with planets roughly like ours. We now know about 2 trillion other galaxies than the Milky Way. And now we're even talking multiverse, that maybe even our entire universe is just one member of an ensemble of a huge number, almost infinite ensemble of universes. So from a physical perspective, our place has diminished and diminished. However, notice that from a philosophical perspective, at the same time, what has happened is that every sentence I said before actually represented a human discovery. When Copernicus found what he found, a human discovered that. Then Harlow Shapley discovered we're not at the center of the Milky Way. Then Hubble discovered there are other galaxies. Now we're talking multiverse. These are all human discoveries. In other words, as our universe expanded, it expanded just as fast as our intellectual horizons have expanded. So in that sense, we actually play a central role in this grand scheme of things.
What are the implications of the discoveries in cosmology for traditional religious views, particularly from the Judeo-Christian tradition?
I have friends who are very religious people, superb scientists. And I actually asked some of them, what is their view? All the people I talked to came back with the same answer, which was, I actually believe that everything that we see goes by the laws of physics. But who determined what the laws of physics are, that's where they bring in the deity. So to them, God determined what are the laws of physics, and then basically everything follows the laws of physics.
How do you feel about that?
I'm not a religious person myself, so to me, laws of physics are what the laws of physics are. It doesn't mean that somebody had to determine what those laws are.
So to you, the laws of physics might be, as we call, a brute fact. There's something that's there that's unexplainable, and
well, in particular,
that doesn't bother you.
If there is a multiverse, which is essentially infinite, it could in principle be that every combination of laws of physics is out there in one of these members of the multiverse. And then we, of course, find ourselves in one of those universes where the laws of physics allowed for our existence.
But you still need a series of meta-laws to generate a multiverse to come to that conclusion. So you've just...
You need certain level of assumption.
So you've just changed the level of which you've asked the question, but it's the same question.
That's true. It's the same question, you know, how did we get there? Yeah.
To Mario, humanity's comprehending the cosmos reveals humanity's minuscule place in the cosmos. The final step, now taken by cosmologists, is a multiverse. The remarkable idea that there are multiple universes, perhaps an infinite number of universes. A multiverse emerges from two kinds of reasons: as the theoretical consequences of our best theories of how the universe began, and as a natural way of explaining what seems to be an astonishing fine-tuning of the laws of physics to allow our kind of universe with stars, planets, and life. I feel diminished by my insignificance, but paradoxically, I feel enlarged by my awareness of it. That, I realize, is what philosophy of cosmology is all about. But is this multiverse real science? And how would the existence of a multiverse, or its non-existence, inform a philosophy of cosmology? Attending the conference is a cosmologist with whom I've long wanted to discuss such matters. The distinguished South African expert on space-time and general relativity, George Ellis.
George, you've been dealing with cosmological subjects for more than half a century. What seem to be some astonishing ideas have become mainstream. Inflation theory, how the universe began, multiple universes. So what seems to be emerging is this sort of a philosophy of cosmology. How do we analyze cosmology in this time of really dramatic transformation?
I think we've got to recognize that we're coming at a certain level to the limits of what we can see in the following sense. We can see anything which comes towards us at the speed of light, and that'll be electromagnetic radiation, X-rays, ultraviolet, and so on. But we cannot see further than that. Now, we have seen out to the last scattering surface where the cosmic microwave background radiation was let free by the matter and come traveling towards us. That is the furthest matter that we will ever see by any electromagnetic radiation. The philosophy of cosmology is going to have to get to terms with that fact that there is this visual horizon, and that's the limit to what we're ever going to be able to see.
So what's the implication of that for cosmological theory?
If one starts positing theories of what lies beyond the visual horizon, they're not testable in the conventional sense. And so if you're going to produce a multiverse theory, we can't see those other universes, we can't interact with them.
Well, the motivation why they come to a multiverse is multiple. And on the one hand, it seems to be the forced consequence of inflation theory, of how this universe started, and the multiverse is a natural consequence of that. There's another motivation that seems to be driven by fine-tuning that says, how do you get fine-tuning? And that so there seems to be two independent ways of getting at the multiverse.
Yes.
So it's
So the first one is through inflation, and I think it's important to understand that not all inflationary models lead to a multiverse. It's a subset which lead to them. Anyhow, the bottom line is that the fact that we have inflation makes a multiverse a possibility, but not a necessity. The second point is that the philosophical motivation is for fine-tuning, and particularly the cosmological constant. And very briefly, if the cosmological constant was very much bigger than it is, we wouldn't be here because structures wouldn't have formed. And so we want to explain why that should be the case. That is a philosophical justification. And so the question that cosmologists have to ask themselves is, if I have a philosophical justification for a theory such as the multiverse, does that prove it exists? And this takes us back to the roots of science. does philosophy prove the stuff about the real world? And I think we know the answer to that. Since the scientific revolution, we've known that you can have any theories you like, but you want to actually be able to test them.
Right.
We need to be careful with the multiverses, saying they're very attractive philosophically in many kinds of ways, but once you want to say they are an established part of science, you've got to produce some convincing proof. And for many multiverses, it's basically not possible to get that proof.
What you say is on the surface true. What do you do at that point? You can give up, which nobody wants to do. You can try to find other indications in our world. You can look for coherence. Which of the explanations that you can have seem to be the most simple?
Yes.
Occam's razor, that you don't have to multiply entities.
Yes.
You can figure out alternatives, even if you can't prove them scientifically, and look which seems more logical.
Yes. So Occam's razor you can use in many different ways, and my own view is that with the multiverse, you are multiplying entities far beyond necessity. You're trying to explain one universe in terms of billions of other universes. A particular point which is very important here, the multiverse literature is replete with the word infinity. Now, one thing I will say with total confidence is that any theory which talks about infinities of physical entities is not a scientific theory, because there isn't any possibility whatever of proving that an infinity of anything exists.
Yeah, so what's your current position on this totality?
I think in particular what we need to do is look for other ways of explaining the values of the constants. And if you get such an explanation, then you don't need any of this multiverse stuff to explain it. What I do think is we need to get more clarity on the philosophical issues, and I think it's a complete fallacy to think that the multiverse solves the fine-tuning problem, because all of those problems recur at the level of the multiverse. So I can produce for you a multiverse theory in which no universes allow life, or in which many universes allow life. And so your question is, where do the laws of physics for the multiverse come from? Where do the constants for the multiverse come from? Why are they tuned so as to allow life to exist? And so the multiverse does not solve any fundamental issues. The fundamental options are pure happenstance, it just happened to be that way. Inevitability, it had no other option to being that way. It is high probability, it was very probable it will be that way, which is basically the multiverse option. And then a design or intent kind of thing that somehow or other, something intended that it would be that kind of way. Now the physicists by and large don't like the last one because it's taking them outside the domain of physics. And their assumption is that physical causation is the only causation at work in the universe. Now, that is manifestly a false statement within the universe. Whether it applies to how the universe came into existence is a separate kind of issue.
George questions a multiverse with two kinds of arguments. First, if a multiverse cannot be tested, how can it be counted as science? Second, how could a multiverse truly solve the fine-tuning problem, especially if it is burdened with infinities? Both questions exemplify the probative power of philosophy of cosmology. But what about the deep question of how the cosmos can develop and unfold, the nature of time? At the conference is a philosopher of science at Columbia, the co-director of the Philosophy of Cosmology project, and expert on the foundations of physics, David Albert.
David, in order to understand cosmology, an understanding of the arrow of time is critical. You've talked about something called a past hypothesis to give us a really deep understanding of what this arrow of time means. How does that work?
There's an enormously pervasive sense of there being a profound difference between the past and the future. And I think it's helpful to divide this temporal asymmetry into three broad categories. First of all, there are a whole bunch of ordinary physical processes: ice melting, soup cooling, smoke dispersing, so on and so forth, that we see happen in one direction but not in the other. We never see smoke collecting back into a cigarette. This is a category of asymmetries that's well summarized by the laws of thermodynamics. There's another category of asymmetries, so-called epistemic asymmetries. we have a very different kind of epistemic access. That is, we have a very different kind of capacity to know things about the past than we do about the future. If somebody says, I'm thinking of an occasion when an egg dropped on the floor and splattered in exactly the shape of Argentina, as chance would have it, we know, unless they're lying, they're talking about a past incident, not a future one. That's not the kind of thing we ever know about the future. And it's perfectly obvious to everyone that we know all sorts of things about the past that we can never at present know about the future. Good. Third, there's what's called a causal asymmetry. That is, we make our way around in the world with a very profound conviction to the effect that what we do now can affect the future, but can do absolutely nothing about the past. And it has been wondered for a long time if these asymmetries have anything to do with one another, and if they can be traced back to some deeper feature of the structure of the world. But in recent years, people have been able to formulate more and more precisely the hope that all of these asymmetries can be traced back to very special conditions that existed at the time of the Big Bang. That in particular, if you suppose that at the time of the Big Bang, a quantity called the energy of the universe had a very, very small value, that there's some hope that we can account for all of these phenomena, not merely the thermodynamic one, which has very directly and obviously to do with entropy, but also the epistemic asymmetry and also the causal asymmetry.
And the epistemic and causal as well, to go back to the beginning of the universe?
Yes, that's right. That's right.
That's not intuitively obvious.
It's not intuitively obvious at all, but it seems to me that it's because the initial entropy of the universe was so low that we can have things like records or photographs of past events, but not future events. And that by acting now, we can affect the future, but not the past.
Okay, so go through that. Define entropy in the context of that differentiation.
Entropy in thermodynamics is a measure of how many ways a certain state could be realized. That is, there's a cup of coffee in front of me now. There are a lot of particular arrangements of the atoms in this cup of coffee which would still count as a cup of coffee with the same temperature and the same volume and so on and so forth. What we mean by the entropy of a particular physical state is some account of how many different exact micro conditions would be compatible with that macro condition. It's been known for a long time that if the universe started out in low entropy, that would give a good account of why smoke spreads out but never recollects into a cigarette, of why ice melts but never refreezes in a warm room.
Simplistically, order to disorder?
That's right, order to disorder. What's a little bit more surprising is that this pattern of going from order to disorder can also provide an account why there could be such a thing as, say, a record or a photograph of a past event existing here in the present, but not a future one.
What are the implications for cosmology as we looked from the beginning of the universe into what looks to now its ultimate dispersion trillions of years from now?
Well, one of the things that's inherent in these kinds of considerations is that there is this very surprising consequence that things that look like very local features of our lives here on Earth, that I can affect the future by acting now, but not the past, that I can remember past events but not future ones. If you trace these back to the deepest level, you're really talking about cosmic scale features of the universe as a whole.
Philosophy of cosmology seeks deepest levels of cosmic reality, asking fundamental questions about the universe. How to characterize and integrate the essential components of the cosmos: space-time, energy, matter, laws, regularities. How to articulate the minuscule place of humanity in the cosmos with humanity's penetrating understanding of how the cosmos actually works. How to assess the presumption of a vast ensemble of universes and whether physical causation is the only causation. How does the quantum world and the nature of time affect the universe, its beginning, evolution, structure, and future? I find myself at once exhilarated and troubled. Exhilarated by the ineffable majesty of the universe. Troubled by the radically opposed realms of its possible meanings. Not many working cosmologists concern themselves with philosophy of cosmology. Why should they? Why distract themselves from the hard business of teasing out the universe's ancient secrets? As for me, I must concern myself to be closer to truth.
For complete interviews and for further information, please visit closertotruth.com.